Welcome to Gifted Science and Technology Chemistry class. I'm NC Joshua. Today we'll be looking at hydrogen and compounds. Now let's take some little points about hydrogen. Hydrogen is also called water former. The electronic configuration of hydrogen is 1s1. Who discovered hydrogen? Hydrogen was discovered by Henry Cavendish and was named by Lavoisier. Hydrogen can be, now take note of this, hydrogen can be grouped as group 1, can be grouped as group 1, can be grouped as group 1, and also as group 7A, which is group 17. Hence, because of this, we call hydrogen a rogue element. So hydrogen can exist, has the properties of group 1, that's alkali metals, and also group 7A, which are the halogens. How? Hydrogen has one electron in its outer shell, hence it can behave as group 1, the alkali metals. Hydrogen can receive one electron to attain stability. You know group 7A element or the group 17 element, which are the halogens, they receive one electron to attain stability, octet configuration. So hydrogen can receive one electron also to become stable, doublet stability. So each receiving one electron makes it behave as an halogen. It having one electron in its outer shell makes it behave as the alkali metals, which are the group 1 elements. Hence, hydrogen is called a rogue element. Now, let's see something about hydrogen. Hydrogen has the ability to exist in isotopes. So we have three isotopes of hydrogen. The first one is called the protium, which is H11. The second one is called the deuterium, while the third one is called the tritium. There is something about the tritium. This is also called heavy water. Deuterium is also called heavy water. This is radioactive. Now take note, the isotope of hydrogen that is radioactive is tritium. Now look at these isotopes and how it plays out here in their number of proton, electron, and neutron. Now hydrogen, once you see something here like this is referred to as the atomic number or the number of proton present. So if you check here, 1, 1, 1, the number of proton here is 1, which is the atomic number. Number of proton here is 1, number of proton here is 1. So it means proton, deuterium, and tritium, they have 1, 1, 1 in their number of proton. Now, what about the number of electron? Now, because these isotopes, there are no charges present, hence they are neutral. So an atom in a neutral state, the number of proton equals number of electron. An atom is said to be electrically neutral when the positive charge equals a negative charge. Protons are positively charged, electrons are negatively charged. So it means that for this case, since there is no charge present here, the number of protons equals the number of electrons. So electron number is 1. For this case, the number of proton equals number of electron. Electron also here is 1. For this case, number of proton equals number of electron. Electron number is also 1. What about neutron? Neutron is equals proton. Neutron number is equals mass number minus proton number. Neutron number equals mass number minus proton number. Where is our mass number? These are mass number up. These are mass number. These are mass number. So now neutron number equals mass number. My mass number here is 1 minus proton number is also 1. 1 minus 1 is equals 0. For this case, neutron number is mass number, which is 2, minus proton number, which is 1. The answer is 1. For this case, neutron number is mass number, which is 3, minus proton number, which is 1, is equal to 2. So you see that protium as an isotope of hydrogen has no neutron, but deuterium has one neutron, then tritium has two neutrons. So if you check, they have the same proton number, hence they are called isotopes. They have the same electron number, but they have different neutron numbers. So we can say isotopy is due to the difference in neutron number. So the phenomenon whereby an atom of an element have the same atomic number, which is the number of protons, but different mass number is called isotopy, and that phenomenon is due to difference in neutron number. What are the properties of hydrogen? Hydrogen is neutral. Hydrogen is neutral to litmus. The next one is lighter than air. The next one is tasteless, is odorless, and is colorless. Now, there are certain points I want you to know about hydrogen before we go into its preparation. The first one is that hydrogen does not occur in free state in the atmosphere except as in volcanic gases. So the only time you see hydrogen in free state is only in volcanic gases. Another point I want you to know is that the sun is about 90% hydrogen by mass. The sun is about 90% hydrogen by mass. Now let's see preparation of hydrogen. Number one, we'll be looking at action of reactive mentals on acids. Now, elements that are above hydrogen on the electrochemical series are referred to as reactive mentals, and so such elements we can use them in preparation of hydrogen. But take note of this, that potassium, calcium, sodium, and calcium, potassium, sodium, and calcium react explosively with dilute acid. So it means that these elements cannot be used, although they are reactive mentals, but we cannot make use of them. Why? Because they react explosively. Now, there's another point you have to note is that triazonitrate 5 acid, concentrated triazonitrate 5 acid or concentrated H2SO4 is not used in the reaction. Why? Because they are strong oxidizing agents. So now take note, what is used? A dilute H2SO4 is used. Even a dilute HNO3 cannot be used. Why? Because it's a strong oxidizing agent. Take note of this, is a strong oxidizing agent. So I have dilute H2SO4 can react with zinc to give us zinc sulfate and hydrogen gas. Now take note of this. Why is it not possible to use concentrated H2SO4 but dilute? Because it will oxidize hydrogen into water. You see, instead of hydrogen gas, we are now having water. That's why it will not allow this nor this in its concentrated form to be used for such reaction. Rather, I'll be using zinc plus dilute H2SO4 to give us zinc sulfate and hydrogen gas. Now take note of this, the zinc used is not pure, but rather we need an impure zinc. Why do we need an impure zinc? Because if it's pure, it will slow the rate. Now, all these are important terms. It will slow the rate of the reaction. It will react slowly. But if it's impure, it will react faster. Now, what about if I want to use a pure zinc? If I must use a pure zinc, I should add an impurity. Now, what can be added? I can add copper sulfate, copper 2 tetra also super 6 into it to be as a catalyst. It will help the reaction to occur faster. So CuSO4 can be added as a catalyst in this reaction if the zinc used is pure. Now, what next? Hydrogen is collected over water. This reaction to produce hydrogen, the hydrogen gotten is collected over water and is collected by an upward delivery. Why? Because it's lighter than air. Remember, we said hydrogen is a light gas. So hydrogen is lighter than air, hence it can be collected by upward delivery. So you have that here. The hydrogen is collected over water by upward delivery. Another name for upward delivery is called downward displacement of air. Upward delivery or downward displacement of air. Downward delivery or upward displacement of air. Take note of that, don't make mistakes. Upward delivering is also called downward displacement of air. Then while downward delivering is called upward displacement of air. Gases that are lighter than air, we collect them by upward delivery, while those that are heavier than air, we collect them by downward delivery. Now, it means that the hydrogen gotten, since it's collected over water, is moist. So how can we make the hydrogen dry? We make it dry by passing moist hydrogen interfuse calcium chloride. This is a drying agent. Then when we do that, we get a dry hydrogen. Then finally, take note, hydrogen is collected over mercury. Now we have other ways of laboratory preparation of hydrogen. Another way is by action of cold water on reactive benter. So when you have a cold water and you have a reactive benter such as sodium, such as lithium, such as potassium, you have a kind of a vigorous reaction occurs. Now what happens is that if you have a case like this, which is now sodium plus H2O liquid, it will give you sodium hydroxide plus hydrogen gas. So you realize that what happens here is that you have an alkali is formed. An alkali is formed in the process. Now what happens? You see that the red litmus paper in the solution turns blue. So an acid turns blue litmus paper red, or an alkali turns red litmus paper blue. So you have a kind of a bluish coloration in the solution. Why? Because the litmus added, which is the presence of the alkali form, turns blue. So this is for this reaction. Now I want you to note the following terms. Sodium reacts vigorously with water. Lithium reacts steadily with water, but potassium reacts explosively with water. It's very important, and this is the reaction for this. Now we have the third way, or one of the third process. The third process in laboratory preparation, we have action of steam on red hot iron. Now I want you to see the reaction here. This is iron, then this is steam. Then this is what is being produced. Remember we said that this consists of FeO and also Fe2O3. These are the two compounds in this compound, and this is called ion 2 diion 3 oxide, ion 2 diion 3 oxide. That's what this compound is called. So when this ion reacts with steam, it gives us ion 2 diion 3 oxide and liberates hydrogen gas. This is one of the process that produce a wide scale or a large scale of hydrogen gas, and is very cheap. So this is one of the process, or one of the way you can get, is one of the cheaper way, or the cheapest way you can get a lot of scales of hydrogen gas. Now, please take note of this. It's very important. Potassium, sodium, calcium displays hydrogen from cold water, just as I have it here. In this case, action of cold water on reactive metals. So such reactive metals are your potassium, sodium, and calcium. Magnesium displaces hydrogen from hot water. Take note of this, is very important. While zinc, iron, or lead displaces hydrogen from steam. This is a very important point that you need to know. As you're going through this class, take some past questions and start saying some attempt of some questions with the knowledge you are gathering about hydrogen and its compound. Now let's look at industrial preparation of hydrogen. Now we have bioelectrolysis from hydrocarbon, natural gas, which is a good example is your methane, from water gas, and from cracking of petroleum. Now let's see the first one, bioelectrolysis, electrolysis of brine. Now remember in our electrolysis class, we said during electrolysis of brine you have, brine is concentrated sodium chloride. If you dissociate, it will give us Na plus Cl minus. In the presence of H2O, it will give us H plus OH minus. We said these two hydrogen will be preferentially discharged at the cathode, while we said chlorine gas will go to the anode. Now what happens? This will not be H plus 2E minus to give us H2 balanced, while this will not be Cl minus to give us Cl2 plus 2E minus. This is 2, or we have it as Cl minus minus 2E minus to give us Cl2. Any of them is allowed. We did this in our electrolysis class. So we now say that the leftover in the solution will be sodium and OH. Hence, the solution in the alkali solution, the solution of the electrolyte will be alkalinic. So we now said electrolysis of brine will give us three products. What are the three products? Number one, hydrogen. Number two, chlorine. Number three, sodium hydroxide. So electrolysis of brine using carbon-carbon electrode or platinum-platinum electrode has the tendency of giving us hydrogen gas. And where is this hydrogen gas coming from? It's coming from the cathode. So this is the cathodic reaction of number one. This is by electrolysis. Now, number two, let's see from hydrocarbon. From hydrocarbon, a good example, natural gas is what now is methane gas. You know, methane is a major constituent of natural gas, while butane is a major constituent of domestic gas. Now, let's look at this. How do you produce hydrogen from natural gas? By passing steam through natural gas. So we have methane CH4 plus steam, which is H2O. Now, what would this is gas. What would this give to us? It will give to us CO gas plus uh, plus H2 gas. Now, you see that we have this as our product. What happens to this? In order to make it balance, I'm having 4 here, 6, so I have 3 here. Now look at this. There is already a trace of carbon 2 oxide in the reaction. There is already a trace of carbon 2 oxide in this reaction. To remove the carbon 2 oxide, to remove the CO oxide, which is a gas, will keep bubbling or keep adding steam into the solution. So I keep adding steam into the reaction. So this is my product. So I will keep adding steam to this product. So now I have CO as gas plus what now? 3H2 as gas, then plus H2O. This is steam. So what is the essence of this additional steam? Is to remove the trace of carbon 2 oxide. What will I now have? I will have CO2 plus H plus H2. So that becomes the answer to this. Why this will not be 4 to make it balance 8, as this is now 2 and this is 1. Now look at this. We have a trace of CO2 gas of carbon dioxide. So in this reaction, I want you to know we have a trace, a small trace of CO, which is carbon dioxide, and we have a trace of CO2, which is carbon dioxide. This is how the reaction occurs when steam is passed through, when steam is bubbled or passed through methane for production of hydrogen gas. So now, how can we remove carbon 2 oxide and how can we remove carbon 4 oxide? You can remove carbon 4 oxide by passing it through calcium oxide, calcium hydroxide. You can remove carbon 4 oxide through this, or you can also remove it by passing it through calcium hydroxide. So we can remove carbon dioxide by passing the gas produced through calcium hydroxide or potassium hydroxide. So, but what about the carbon 2 oxide? You can remove the trace of carbon 2 oxide by passing it through ammoniacal solution, ammoniacal solution, ammoniacal solution of copper 1 ethanoate. Now, please take note of this. The trace of carbon 2 oxide can be removed by passing it through ammoniacal solution of copper 1 ethanoate, but the carbon 2 oxide, the carbon 4 oxide can be removed by passing it through potassium hydroxide or calcium hydroxide. Now, another way we can, now let's see number 3, from water gas. Now, what is water gas? Water gas is a mixture. Water gas is a mixture of carbon 2 oxide and hydrogen. Actually, when you have when you have steam is passed over white hot coke or white hot carbon, you have a mixture of carbon 2 oxide and hydrogen. I reiterate, when steam is passing, when steam is passed over white hot coke, you have this the reaction, you have a mixture of carbon 2 oxide and hydrogen. That's what we call water gas. So when water gas is when steam is passed through water gas, when steam, this is steam passed through water gas, we have carbon 4 oxide and hydrogen. Now take note, this reaction is carried out in the presence of a catalyst. So the catalyst used in this is either iron 3 oxide or chromium 3 oxide. But for from hydrocarbon, the catalyst used here is nickel. Take note of that. Now, take note, in this reaction, we have carbon 4 oxide produced alongside with hydrogen. And this carbon 4 oxide is removed by dissolving it in water under pressure. So we have two ways we can remove the carbon dioxide, either by dissolving this under pressure and hydrogen is left in water and hydrogen is collected over water, or we pass it through calcium hydroxide. So these are the possible ways to remove carbon dioxide from it, and you get your hydrogen gas as what is needed. Thank you. Now we'll be looking at tests for hydrogen. Before we go into tests for hydrogen, I want you to note that the industrial preparation of hydrogen using uh, water gas, take note of that. That process is called Birch process. Take note of that, very important. It's called Birch process. Now let's look at test of hydrogen. We have, if a lightning splinter is inserted into a test tube containing an unknown gas, if the gas is hydrogen, it will burn with a pop sound. So hydrogen gives a pop sound when burnt. So if we insert a lightning splinter into an unknown gas, we say if that gas is hydrogen, it will burn with a pop sound. Take note about this again. Hydrogen burns with a blue flame in oxygen. These are one of the chemical properties of hydrogen. Hydrogen burns with a pale blue flame. More chemical properties here are with mentals. Hydrogen reacts with mentals to form halides. This is a good example of sodium halide and calcium halide. So, sorry, calcium hydride and sodium hydride. So, hydrogen reacts with mentals to form hydrides of the mentals. Now, with halogen, hydrogen combined with halogens such as chlorine to form the chlorides of what now? Of hydrogen. So we have hydrogen chloride, we have hydrogen bromide in terms of which of the halogen is reacting with. And with hydrogen and chlorine, it occurs in the presence of sunlight. Now we have hydrogen as a reducing agent. These are some of the chemical properties of hydrogen. What does it mean if hydrogen is a reducing agent? It means it can remove oxygen from a substance. Remember, this is removal of hydrogen, why this is addition of oxygen. So this is reduction, why this is oxidation. So if this is oxidation, it means this is a reducing agent. So hydrogen is a reducing agent. So it can reduce the oxides of copper, iron, lead to their mentals. If you see the reaction now, copper oxide has been reduced to copper metal. So now we see uses of hydrogen. Hydrogen can be used for hardening of vegetable oil to obtain margarine. This is called hydrogenation reaction. For producing ammonia, this is called Haber process. Remember, from water gas is called Birch process. It can also be used for producing water gas and coal gas. Is still another uses of hydrogen. Is for filling balloon because of its light density. Is for filling balloon because of its light density. Take note, liquid hydrogen is used as rocket fuel. Take note, liquid hydrogen is used as rocket fuel, and also the hydrogen flame can be used for cutting metals. So all these are uses of hydrogen. I want you to take your a question pack and go through this video and try to attempt questions and see that hydrogen compound is an easy one. Thank you.